We'll start with the harmonic oscillator. Just the harmonic oscillator. So we'll first see what harmonic oscillator is in classical mechanics. Classically, it's, we all know, something like this with mass m. So the restoring force is F equals to minus kx, which can be written as minus m t square x by tt square, and we have a solution. Basically xt equals to a sine omega t plus b cos omega t. Yeah, right. Where omega is, as we all know, under root k by m, and potential energy is written as half kx square. So this is everything classically. Next we'll see how do we solve this in quantum mechanics. So we'll see quantum harmonic oscillator. So quantum harmonic oscillator, we all know basically Schrodinger equation. We have Schrodinger equation is just h psi equals to e psi, where psi is wave function, h is Hamiltonian, e is your energy value. So what is h? Minus h square, h cross square by 2m t square psi by dx square, h psi, plus potential psi. So in this case harmonic oscillator case, v is equals to half m omega square x square. So we'll put this value of v here, and then we just have to solve this differential equation and we can get value of energies. So what I'll do is just feed the values of v in this equation, and we have this minus h cross square by 2m t square psi by dx square, and as we all know, v half m omega square x square psi is equals to e psi. And this is our Schrodinger equation for quantum harmonic oscillator. We have to solve this differential equation and get the values of E which we want. So this equation is not quite straightforward, so we have to use different tricks to solve this. So among them I'll be doing the two which are normally used. First is brute force method, or second is ladder operators. So this uses power series expansion, and this is kind of algebraic method. We'll see as we proceed. So let's start with the algebraic. First we'll start with ladder method. So what we'll do is just we'll rewrite the Schrodinger equation. Remember the Schrodinger equation, this one. Plus half m omega square x square psi equals to E psi. This is our Schrodinger equation, and just we will rewrite this. How we'll rewrite this is basically take 1 by 2m common. Okay, and as we all know, I square is -1, so this will become h cross by I d by dx square plus m omega x square psi equal to E psi. So I hope this is not very confusing, because we just took 1 by 2m common. If you take this 2m here, it will become minus, again it will become the same, which is the above equation. So this is something we can write as, suppose this is u and this is v, and you know u square plus v square is indeed u minus iv into u plus iv. So what we'll do, we'll just define something called a plus, which is equal to 1 by 2m h cross by I d by dx plus im omega x. Similarly, we will define a minus, which is again the same thing, 2m h cross by I d by dx minus m omega x. So these are two equations which we have, this basically, and if you multiply a minus into a plus, here it gives 1 by again 2m h cross by I d by dx plus m omega x whole square plus half h cross omega. So this is nothing but normal multiplication. So a minus this into this gives this one into this one gives us 1 by 2. Just this one into this gives this, and this cross multiplication gives us basically this. You can see, you can check, cross check if you want. So but what is this? This is also same thing in the Schrodinger equation in which we rewrote. So essentially what we can say is h cross by I, and right on next page. So essentially we can say that h cross by I d by dx whole square plus m omega x whole square by 2m is equals to minus a plus minus half h cross omega. So this is what we got after mixing up Schrodinger equation and the other a minus a plus 1. So next we have our new Schrodinger equation, which is a minus a plus minus half h cross omega psi equals to E psi. So what we guess is now we have this Schrodinger equation. Also we can write the Schrodinger equation in the form of a plus a minus rather than a minus a plus. So in form of a plus a minus, it is a plus a minus plus half h cross omega psi equal to e psi. You can just try and multiply a plus first into a minus. It's the same thing. So what we do is, now we essentially have psi satisfies the Schrodinger equation. What we claim right now is, if psi satisfies Schrodinger equation with energy E, then a plus psi satisfies Schrodinger equation with energy E plus h cross psi. This is the basic thing why the ladder operator works. Ladder means going up or down, so this is basically going up, E plus h cross psi in a step of h cross psi. So this is our claim, and we'll try to prove our claim. The proof. So proof is something like this. So a plus a minus plus half h cross psi into a plus psi, of course, equals now a plus a minus a plus half h cross omega a plus psi e plus psi. And now we so what we did last was, what we did last was a plus a minus plus half h cross omega into a plus psi, and we multiplied a plus inverse, so a plus inverse multiplied is a minus a plus half cross omega a plus. Now we will take a plus common, a minus a plus half h cross omega, and this becomes again e, not e actually, and this is a plus a minus a plus minus half h cross omega, and to balance out we have h cross omega, and this was e from our new Schrodinger equation. So this is e plus h cross omega. H cross omega, yeah, correct. I think we forgot psi everywhere. Just multiply psi. So what we essentially say is a plus a minus plus half h cross omega a plus psi is e plus h cross omega into a plus psi. So we see e plus h cross omega does satisfies a plus psi does satisfy this equation, and similarly a minus psi satisfies this equation, and it gives the new energy of e minus h cross omega, and a plus psi gives the new energy of e plus h cross omega. So this is why this is called a ladder operator. Ladder operator where a minus is called lowering or annihilation operator, and a plus is called raising operator. and if you apply A minus repeatedly, the energy goes by just one step, like A minus psi, the energy would be E minus 2h cross omega, and similarly A plus psi, it will give E plus 2h cross omega. So this was all about weird ladder operators. Let me see the other way to solve this equation, Schrodinger equation for quantum harmonic oscillator. So if you apply if we apply A minus operator repeatedly, then at some point E can get less than 0 at some point. So there must be a value of psi where A minus psi naught is equal to 0. Minus is in subscript. A minus psi naught is equal to 0, and for this what we can do is just substitute A minus, and we can calculate psi naught this way: h cross by I d psi naught by dx minus I m omega x psi naught is equals to 0. So this we need to solve to get value for lowest psi naught such that E is not equal to 0. So after solving the last differential equation, the normal general value of those functions are like this, which I am now writing it. This A naught exponential minus m omega by 2h cross x square, and this is the lowest, you can say lowest wave function, which can give non-negative value for the energy. You see, E is total energy, so it must be greater than 0. So this is the lowest wave function which could be used. So now just put psi naught in. Just let's try and put psi naught in this Schrodinger equation. This is the Schrodinger equation, right? Which actually kind of modified Schrodinger equation. Let's put this here and see what happens. So we know that A minus psi naught is 0. We know A minus psi naught is 0. So what we essentially get is this part becomes 0 after multiplying with psi naught. What we essentially get at the end is E naught equals to half h cross omega, which corresponds to ground state of quantum harmonic oscillator. So the ground state energy is E naught. I am writing this side, half h cross omega. Okay, so we have this. So let's try and apply raising operator E plus to get the next value of psi naught, like psi naught, then psi 1. So we can say psi n equals to En A plus power n e raised to power minus m omega by 2h cross x square. So this is kind of a generator thing, like you put the value of n, like we know the value of psi naught. So if you put n equal to 1, you can get psi 1, similarly psi 2, psi 3, psi 4, and all the next steps. So we'll calculate psi 1 right now. So psi 1 is A plus, of course this is A plus e to the power minus m omega by 2h cross x square. So we know what is a plus. A plus is 1 by root, not right here, no space here. A plus is 1 by root 2m h cross by I d by dx plus I m omega x exponential, I'll take this space, m omega x square by 2h cross this. So just put here and use this operator, and you will get the value of psi 1, which is something like this. I'm just directly writing is I a1 omega under root 2m exponential something m omega x square by 2h cross. This is psi 1. Similarly, after doing some extensive calculation like a psi double 2 times, you can get psi 2, psi 3, psi 4. Similarly, you can get this psi 1, psi 2, psi 3, and similarly you can get energy for the each eigenstate, which is what we essentially needed to calculate for this part. So thanks. I will just finish the ladder operator here, and I'll start with analytic method in thanks.